These two players have played 10 matches in all. Who's better? Here's the comparison of their performances.
Looking at the average, player 16 is definitely better.
Welcome to the lesson on the mean of grouped data. At the end of this lesson, you will be able to define the mean of grouped data. You will also be able to calculate the mean of grouped data using the direct method, the assumed mean method, and the step deviation method. Meet Miss Greenfingers. She is actively involved with the tree plantation programs in her city, but looks like something is troubling her. Here is the data for the tree plantation program that Miss Greenfingers recently conducted in 60 schools in her city. Now she has to find the average number of trees planted in each school. Let's help her to do it. First, let's observe the table carefully. What does it represent? The table shows the data for a tree plantation program as a grouped frequency distribution table. To find the average number of trees planted in each school, Miss Greenfingers has to find the mean of this grouped data. Recall that the mean of a given set of data is equal to the sum of the values of all the observations divided by the number of observations. There are three ways of calculating the mean: the direct method, the assumed mean method, and the step deviation method. Let us learn about these methods in detail. Let us begin with the direct method. What do the two columns in this table represent? The first column represents the class interval of group data, and the second column represents the frequency for each class interval. The first step to finding the mean of grouped data using the direct method is to find the class mark for each class interval. Let's denote the class mark as xi. The xi for each class is equal to half the sum of the upper and lower class limits of each class interval. Using the formula, we can calculate the class mark for each class interval. The class mark for the first class interval is equal to half the sum of 5 and 25. That is, half of 30, which is 15. Similarly, the class mark for the second class interval is 35. The remaining class marks are calculated and given in the table. Next, let us find the product of the frequency and the class mark for each class interval. This is denoted by Fixi. Now observe carefully how we calculate the value of Fixi. As you observed, for the first class interval, Fixi is the product of 12 and 15, which is equal to 180. Similarly, for the second class interval, Fixi is 280. The remaining products are shown in the table. Now, let us find the sum of the products of the frequencies and the class marks for all the class intervals. This sum is represented by summation Fixi, which is equal to 3300. We are close to finding the solution for Miss Greenfinger's problem. The mean x-bar of this grouped data is equal to the sum of the products of the frequencies and the class marks for all the class intervals divided by the sum of all the frequencies. On calculation, we get the mean of the given grouped data as 55. Thus, the average number of trees planted in each school is 55. We arrived at this result by calculating the mean of the given data using the direct method. This method involves a lot of multiplication and addition. This method can be tedious if the class intervals and frequencies are large. Let us see if there is a simpler way to find the mean of group data. let us go back to the data table. We'll take up from the step where we calculated the class marks for the class intervals in the given data. We'll try using a different method, the assumed mean method for finding the mean. This method can also be used when the size of the class is not the same. Observe the class marks for different class intervals. Let us assume any one of these class marks to be the mean of the given data. Let's choose 35 as the assumed mean denoted by A. Now, let us find the difference between the class mark for each class interval and our assumed mean. We'll term it as deviation and denote it as DI. The deviation for the first class interval is 15 minus 35, or minus 20. Similarly, for the second class interval, the deviation is 35 minus 35, or 0, and so on. Now, let us find the product of the frequency and the deviation for each class interval. This is denoted by FI/DI. For the first class interval, this product is 12 multiplied by minus 20, which is equal to minus 240. Similarly, for the second class interval, this product is 0. The product for the remaining class intervals are calculated and shown in the table. Next, we'll find the sum of the products of the frequencies and the deviations from assumed mean for all the class intervals. This sum is represented by the Greek symbol summation and read as summation. In this case, this sum represented by summation FI/DI is equal to 1200. Now, let us see how we can use this value to find the mean of the given grouped data. For this, we will have to derive a formula. Let's consider the summation FI/DI. Since DI is equal to xi minus a, we can substitute this in the above equation. Next, we'll divide both sides of the equation by summation Fi. The right side of the equation can be expressed as follows. Since summation Fi/xi divided by summation Fi is equal to the mean x bar, let's rearrange the equation. Here, x bar is the mean, a is the assumed mean, and summation Fi/DI divided by summation Fi is the mean of deviations. Thus, we arrive upon a formula where the mean of the given data is equal to the sum of the assumed mean and the mean of deviations. Now, let's use this formula to calculate the mean of the given grouped data. Substituting the values and calculating, we get the mean of the given grouped data as 55. This method is called the assumed mean method to find the mean of grouped data. Thus, we see that the mean found using the assumed mean method is in agreement with the value of the mean found using the direct method. Now, let us see if we can further simplify the calculations using another method to calculate the mean of grouped data. Let us go back to the step in the assumed mean method, where we chose one of the class intervals as the assumed mean and found the deviations for all other class intervals. We'll rework from here using a different approach. Observe the class intervals in this table carefully. Note that the class size for all the class intervals is 20. The class size is the difference between the upper class limit and the lower class limit. It is denoted by the letter H. Now, for each class interval, let us divide the deviation from assumed mean by the class size. This value is denoted by UI. The value of UI for the first class interval is equal to minus 20 divided by the class size 20, which is equal to minus 1. Similarly, for the second class interval, this value is 0. The remaining values are shown in the table. Now, let us find the product of ui and the frequency fi for each class interval. This is denoted by fiui. For the first class interval, this product will be equal to 12 into minus 1, which is equal to minus 12. Similarly, for the second class interval, this value will be 0. The remaining values are provided in the table. Now, let us add the products of fi and ui for all the class intervals. This value summation fiui in this case comes to 60. Now, let us see how we can use this value to find the mean of the given grouped data. This involves a bit of derivation. Let us start with the relation we found in the assumed mean method. Since ui is equal to di divided by h, we can say di is equal to the product of ui and the class interval h. Substituting this value in the equation, we find a relationship between the mean x bar, ui and h. Further substituting in the values, we find that the mean of the given grouped data is 55. This method is called the step deviation method. It is also used to find the mean of grouped data. Thus, we see that the mean found using the step deviation method is in agreement with the value of the mean found using the assumed mean and the direct method.